Okay, we want to differentiate x cubed, and we're going to use the definition of the derivative to do that. Another way to say this is we want to find d dx of x cubed. So we can think of this as an operator that operates on this function, and what it does is takes the derivative, and we're going to use the definition to do that. Another way to say this whole thing would be if y is equal to f of x, which is x cubed, find dy dx or f prime of x or d dx of x cubed. So we're going to use the definition. So f prime of x is the limit as h goes to 0, f of x plus h minus f of x all over h. So that's the definition of the derivative, and we want to apply this to this function right here. So here's where I see my students make mistakes for the first time. F of x plus h is the whole quantity x plus h cubed. It's not x cubed plus h. So x plus h quantity cubed minus x cubed all over h. The next place I see my students make a mistake is trying to expand this x plus h cubed. So I just want to remind you, as far as these binomial expansions, x plus h to the 0 by definition is 1. X plus h to the 1 is just x plus h. X plus h squared, of course, is x squared plus 2xh plus h squared. And x plus h cubed is what I get when I multiply this by x plus h. It will come out to be x cubed plus 3x squared h plus 3x h squared plus h cubed. So it's pretty easy to get these exponents. You can see the exponents on x just decrease by 1 starting with this power right here. So 3, 2, x to the 1, this is x to the 0, and they go up on h starting at h to the 0, h to the 1, h to the 2, h to the 3. The hard part is getting these coefficients here. So if I say, well, the coefficient, that is 1, the coefficients here are 1, that's 1, 2, 1, 1, 3, 3, 1. How am I going to get those coefficients? Well, you get them by a thing called Pascal's triangle. So here's this diagram again without all the variables. So just 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And after you look at this for a while, what you realize is that each row always starts with the 1, and then you add the next two to get the one below it. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and it always ends with a 1. So if I wanted to expand x plus h to the 4th, here's the coefficients I would use. So I would have 1, 4, 6, 4, 1. It would start with x to the 4th, and then go down x to the 3rd, x to the 2nd, x to the 1st, x to the 0, and then it would start with h to the 0, so h to the 0, h to the 1, h to the 2, h to the 3, and then h to the 4th. And I know that's really hard to read because I wrote real small. But anyways, that's Pascal's triangle. If you've forgotten that from algebra, that's how you go about it. Or you could just multiply x plus h times x plus h times x plus h. This is exactly what you'll get. So on the next step in this problem right here, this is going to be the limit as h goes to 0 of x plus h cubed. So now we know that that's x cubed plus 3x squared h plus 3x h squared plus h cubed. So from here to here, that's what that looks like, and that's the second place I see my students make a mistake. Minus x cubed, all divided by h. Now, I can simplify this. You see I have an x cubed here minus x cubed. That's going to give me 0. Each of these terms here has an h in it, so I can factor an h out, divide by h, then take the limit as h goes to 0. The rest of this is really pretty easy, and my students don't seem to have much trouble with it. When you've gotten to this point right here, this algebra is easy, taking this limit is easy, and what you get is just simply 3x squared. So the derivative of x cubed, or y equal x cubed, is going to be 3x squared.